In this video of CRV, continuous random variable, we will start with the basics of it. Now, before we get started with CRV, you have heard the name DRV. D stands for discrete, R stands for random, and V stands for variable. We have studied this topic in S1, discrete, random, variable. It's about probability distribution. And then based upon that probability distribution table, we can calculate the expected value, the expectation, and hence the variance of x. Now, DRV was for a discrete variable, a variable which can assume integer values, or when we are dealing with money and currency, yes, the value can be in decimals also. For example, $5.60. So this is an exact value. As opposed to a discrete variable, we can have another variable which we term as a continuous variable. Now, what are the examples of continuous variable? It could be the length of time that a passenger takes when he waits for a bus at a particular station. It could be the distance covered by a ball as it rolls down a slope. So these are some of the examples of a continuous variable. It cannot assume exact values. It has to be a range of values. So CRV, we are starting with the topic of CRV, which stands for continuous random variable. Now, how is it different from DRV, discrete random variable, which we have studied before? Over here, we had a probability distribution table. Now, this probability distribution table was formed either on the basis of calculation of probabilities using a tree diagram or a sample space diagram, or it could be calculated on the basis of permutations, or it could be on the basis of combinations. But when we talk about CRV, continuous random variable, we now have a probability density function, a function that will generate probability for us, and this function will be valid for a certain interval. Let's say that the value of that variable would lie between a and b, and based upon this interval, this function will generate probability, and it will be zero otherwise. It won't work besides these limits. Now, since this is a probability density function, in short, we call it PDF, probability distribution or probability density function. Now, let's draw a graph of this function. So, in general, I can say x goes on the horizontal axis and the function values goes on the vertical axis, and there is a function over here. This function works for the limits a and b. Now, since this is a probability density function, the area under graph represents probability. So area under graph, it represents probability, and we know that the sum of probability should add up to 1. So if we integrate this function between the limits a and b, it should equal to 1. We will use this function in later videos. Also, the probability is always positive. So therefore, the area under graph has to lie above x-axis. It cannot lie below x-axis. And later on, we will use this function to evaluate the expected value and expectation of x square, which is used to calculate the variance of x. Similarly, we will use this function to calculate measures of dispersion. The measures of dispersion that we will calculate will include LQ, that stands for lower quartile. We will be calculating the median. We will also be calculating UQ, that is the upper quartile, and based upon lower quartile and upper quartile, we will calculate the interquartile range. So now, what is this first video all about? That's the introduction of CRV, continuous random variable. How is it similar or different with DRV, discrete random variable? Knowledge of pure math is assumed because this chapter of stats is related with integration. We should be well versed in integrating algebraic functions as well as trigonometric functions and log functions, exponential functions, anything, everything to do with integration within the syllabus. We should be aware of that in order to solve questions related with CRV, continuous random variable.